From the moment humans first gazed out at the vast expanse of the ocean, a dream began to form. We dreamed of harnessing the power of the sea, of unlocking the secrets held within its depths. This dream spurred us to build boats, simple at first, then gradually evolving into complex vessels capable of carrying us across vast distances. These ships, marvels of engineering and ingenuity, became our lifelines to new lands, our conduits for trade and exploration. Today, the allure of the sea remains as strong as ever. Giant ships, some longer than the tallest skyscrapers, are high, ply the world's oceans, carrying millions of tons of cargo and thousands of passengers every year. These floating cities, testaments to human ambition and innovation, are the result of centuries of knowledge and experience passed down through generations of shipbuilders. The story of how these behemoths are brought to life is a fascinating journey into the heart of one of the world's oldest and most essential industries. Step into a shipyard and you'll be greeted by a symphony of industry. The air hums with activity, a cacophony of sounds that speaks volumes about the complex tasks at hand. Giant cranes, their arms reaching skyward like steel giraffes, hoist massive sections of hull into place. Welders, their faces shielded by masks, send showers of sparks flying as they fuse metal together with pinpoint accuracy. Engineers and designers armed with blueprints and laptops scurry about, their every move orchestrated to maintain the delicate balance of this intricate process. This is where imagination takes concrete form, where lines on a blueprint are transformed into steel and flesh. The process begins long before the first piece of steel is cut, with naval architects and marine engineers painstakingly crafting the ship's design. Every detail, from the shape of the hull to the placement of the engines, is carefully considered, optimized for efficiency, stability, and safety. Computer simulations and scale models are used extensively, allowing engineers to test and refine their designs before committing to the full-scale construction. Before a ship touches water, it exists as an intricate web of lines and calculations. Naval architects translate dreams of seafaring giants into tangible blueprints. These complex drawings dictate every curve and angle of the vessel. Years of education and experience culminate in these designs. The process begins with understanding the ship's purpose. Is it a cargo ship, a sleek cruise liner, or a powerful warship? Each vessel has unique requirements influencing its design. Factors like speed, stability, and fuel efficiency come into play. Using CAD software, they create intricate 3D models. These digital blueprints allow engineers to test the ship's performance. Continuous optimization ensures safety and efficiency. The experience and intuition of naval architects bring a ship to life. The digital revolution has transformed shipbuilding. Naval architects now use CAD software to create intricate 3D models. These virtual prototypes allow for testing and refining designs. CAD simulates real-world conditions, testing stability in rough seas. Engineers can tweak designs digitally, making quick adjustments. CAM software translates blueprints into instructions for automated machines. This integration streamlines the shipbuilding process, improving efficiency. Digital twins, virtual replicas of ships, are updated with real-time data. They help monitor performance, predict issues, and optimize maintenance. Section 3. Shaping the Dream. The transition from digital blueprint to tangible hull is a testament to modern engineering. Towering cranes glide along overhead rails, hoisting massive steel plates with grace. Plates are meticulously cut and shaped, their edges beveled and holes pre-drilled. The air crackles with welding torches as workers fuse steel plates together. Each weld is inspected to ensure its integrity, crucial for safety. These dry docks, capable of holding massive ships, are the birthplaces of ocean giants. What was once lines on a screen is now a tangible structure, a testament to human ingenuity. Section 4. Strength in the skeleton. The ship's hull is its backbone, providing strength, buoyancy, and protection. Hull design influences stability, speed, and fuel efficiency. Cargo ships have wide hulls for capacity, while warships have sleek designs for speed. The hull's strength comes from its network of steel beams, ribs, and plates. Longitudinal framing provides integrity, while transverse frames add rigidity. The hull flexes to absorb wave impacts, preventing failures. Ballast tanks adjust weight distribution for stability. Modern ships use computers to monitor and adjust ballast levels for optimal performance. Section 1: An ocean of steel. The vast majority of large ships today are crafted from steel, a material synonymous with strength and durability. But not just any steel will do. Shipbuilding demands special grades of steel engineered to withstand the corrosive effects of salt water, extreme temperatures, and the constant stress of ocean voyages. These high tensile steel alloys, often infused with elements like manganese, nickel and chromium, are significantly stronger and more resistant to fatigue than their landlocked counterparts. The journey from raw iron ore to ship-grade steel is a fascinating one, involving a complex series of processes designed to refine the metal and enhance its properties. It starts in fiery blast furnaces, where iron ore is melted down and impurities are removed. The molten iron is then converted into steel, carefully alloyed, and cast into massive ingots, some weighing over 100 tons. These ingots are then rolled, pressed, and treated to achieve the desired thickness, shape, and mechanical properties. The steel plates that arrive at the shipyard are a testament to this meticulous process, each one a blank canvas for the shipbuilder's art. But even the highest quality steel is vulnerable to the corrosive power of the sea. To protect these steel giants from the relentless assault of salt water, shipbuilders employ a multi-layered defense system. Protective coatings such as epoxy primers and polyurethane top coats create a barrier between the steel and the elements. And then there's the unsung hero of corrosion prevention, the sacrificial anode. These blocks of zinc or aluminum, strategically placed on the hull, act as decoys, corroding preferentially to the steel and thus prolonging the life of the ship. Section 2: The art of joining the giants. Welding is the backbone of modern shipbuilding, binding massive steel plates into a cohesive structure. It's a skilled trade, demanding precision and focus. Shipyard welders often work in cramped, awkward positions, fusing metal with incredible accuracy. Arc welding is the most common method, creating intense heat to fuse steel plates. Methods like SMORE and GMORE are used based on the application and steel thickness. Quality welds are critical, with rigorous quality control at every stage. Automation now plays a significant role, with robotic systems performing repetitive tasks. Yet, the skilled hand of a master welder remains invaluable, ensuring top quality. Section 3: From blueprints to behemoths. The engine room awakes. The engine room is the beating heart of a ship, propelling it across vast oceans, a symphony of steel and wires where diesel engines roar to life. From an empty cavern to a hub of energy, it's an engineering marvel. Installing the engines is a major milestone. These colossal power plants are lowered with millimeter precision. Aligning them demands both brawn and finesse. Once in place, the real work begins. A labyrinth of pipes, valves and pumps connects the engines. It's a three-dimensional puzzle of epic proportions. Electricians ensure a steady supply of power. The engine room is not for the faint of heart. It's a hot, noisy and cramped environment, but for those who work here, it's a place of immense pride. Section 4: Nerves of steel. A ship is more than just steel and engines. It's a complex organism with a nervous system. Miles of cables and wires snake through its steel bones, carrying vital information. This intricate network is the ship's brain and central nervous system. The nerve center is the ship's bridge, a technological marvel. Here, radar systems scan the horizon and satellite communication keeps the crew connected. Laying down the keel, a ceremony of beginnings. The laying of the keel marks the official birth of a ship. It's a moment of immense significance, transforming an abstract concept into a tangible reality. In the heart of the shipyard, a single steel beam, the keel, is carefully lowered into position. This unassuming piece of metal will soon support the weight of the entire vessel. The ceremony varies from culture to culture, but its essence remains the same, to invoke good luck and safe passage. Often, a coin is placed beneath the keel, believed to bring good fortune. Sometimes the coin bears the year of the ship's construction or the image of a deity. It's a tangible link to the past, a reminder that shipbuilding is an ancient craft. With the keel in place, the ship's construction can begin in earnest. From hull to superstructure, a ship takes shape. The keel is laid, and the hull sections grow upwards, resembling its final form. A mesmerizing ballet of heavy machinery and human precision. Massive cranes lift prefabricated sections into place. The superstructure starts to take shape. It houses everything from cargo holds to passenger cabins. Inside, skilled tradespeople install the ship's vital systems. The ship's profile becomes increasingly imposing, a testament to the transformative power of human endeavor. The heart of the giant, engines and propulsion. The engine room, the beating heart of any ship, undergoes its own remarkable transformation during this phase of construction. It's here, deep within the bowels of the vessel, that the ship's massive engines, generators and propulsion systems are carefully lowered into place. These colossal pieces of machinery, often weighing hundreds of tons, are marvels of modern engineering, capable of generating immense power to propel the ship across vast oceans. The installation of the main engines is a delicate and precise operation. Using specialized cranes and hydraulic systems, the engines are carefully maneuvered into their designated positions on massive engine mounts designed to absorb their vibrations. Aligning the engines with the ship's propeller shafts, which transmit power to the propellers, requires painstaking accuracy, ensuring that the entire propulsion system operates smoothly and efficiently. Once the main engines are secured, a labyrinthine network of pipes, valves and pumps is meticulously connected, carrying fuel, lubricating oil and cooling water to the engines. Electricians work tirelessly, connecting the engines to the ship's electrical grid, ensuring a steady supply of power for all onboard systems. The engine room, once a cavernous space, gradually transforms into a symphony of steel, pipes and wires, a testament to the intricate dance of engineering and skilled labor. With the engines installed and connected, the moment of truth arrives, the first engine test. As the engines roar to life, their vibrations reverberating throughout the ship, a wave of excitement and anticipation sweeps through the shipyard. The heart of the giant is beating, pumping life into the vessel and bringing it one step closer to its maiden voyage. Section 4, outfitting the Leviathan from navigation to luxury. The final act in this grand symphony of shipbuilding is the outfitting stage. This is where the ship truly comes alive, transitioning from a hollow steel shell into a fully functional vessel. It's a meticulous process, involving tasks from installing systems to furnishing cabins. The ship's name, proudly emblazoned on its stern, gleams in the sunlight. As the outfitting nears completion, the ship undergoes rigorous sea trials. With each successful trial, anticipation builds towards the ship's maiden voyage. Section 1. The relentless clock, time and tide wait for no shipbuilder. Shipbuilding is a race against time, a constant battle to keep pace with demanding schedules and ever-present deadlines. The sheer scale and complexity of these projects, involving thousands of workers, millions of components and intricate logistical chains, create a breeding ground for delays. And time in the shipbuilding industry is far from an abstract concept. It's a tangible force measured in lost revenue, missed market opportunities, and the ever-looming threat of contractual penalties. One of the biggest challenges is coordinating the myriad activities that must occur in perfect sequence. The late arrival of a single critical component, a turbine blade, a section of pipe, a specialized piece of electronic equipment, can ripple through the entire project, delaying subsequent tasks and throwing the entire schedule into disarray. Shipyard managers employ sophisticated project management software and lean manufacturing techniques to optimize workflow, minimize downtime, and keep the project on track. But even the best laid plans can be disrupted by unforeseen circumstances. Inclement weather can bring construction to a standstill, forcing outdoor work to halt and delaying the arrival of materials and equipment. Labour shortages, strikes or unexpected technical difficulties can also throw a wrench into the works, requiring quick thinking and creative problem solving to mitigate the impact on the schedule. And then there's the ever-present pressure from clients, eager to take delivery of their vessels and put them to work. Shipyards must strike a delicate balance between meeting these demands and maintaining the highest standards of quality and safety. It's a high-stakes game where reputation is paramount and delays can have long-lasting consequences. Section 2. The price of giants navigating financial straits. Building a large ship is not for the faint of heart, especially when it comes to finances. These colossal projects require massive upfront investments, often running into hundreds of millions, even billions of dollars. Securing the necessary funding is a major hurdle, involving complex negotiations with banks, investors, and government agencies. Shipyards must present compelling business cases, demonstrating the viability of the project and their ability to deliver on their promises. The volatile nature of the global economy adds another layer of complexity. Fluctuations in currency exchange rates, raw material prices, and shipping demand can significantly impact the profitability of these long-term projects. Shipyards must carefully hedge against these risks, using financial instruments and strategic sourcing to mitigate the impact of market volatility. Competition in the shipbuilding industry is fierce, with shipyards around the world vying for lucrative contracts. This often leads to aggressive bidding, with shipyards offering competitive prices to secure contracts, sometimes even operating on razor-thin profit margins. This can create a precarious situation where unforeseen delays or cost overruns can quickly turn a profitable project into a financial disaster. To navigate these financial straits, shipyards must be shrewd negotiators, skilled financial planners, and masters of risk management. They must also maintain a laser focus on efficiency, constantly seeking ways to optimize their operations, reduce waste, and keep costs under control. It's a delicate balancing act, requiring a deep understanding of both the art of shipbuilding and the science of finance. Section 3. Nature's Wrath, Humanity's Shield, Environmental Stewardship in Shipbuilding. The shipbuilding industry, for all its contributions to global trade and transportation, has not always been a kind steward of the environment. The construction and operation of large ships can have significant environmental impacts, from the mining of raw materials to the emission of greenhouse gases. However, growing awareness of these issues is driving a shift towards more sustainable shipbuilding practices, with shipyards and shipowners alike recognizing the need to minimize their environmental footprint. One of the key challenges is reducing air emissions. Ships, particularly those powered by large diesel engines, can release significant amounts of pollutants into the atmosphere, contributing to climate change and respiratory problems. To address this, shipyards are increasingly incorporating cleaner technologies such as liquefied natural gas, or LNG, fueled engines, exhaust gas cleaning systems known as scrubbers, and even battery-powered propulsion systems for shorter routes. Another area of focus is reducing water pollution. Shipyards generate a variety of wastewater streams containing paints, solvents, heavy metals, and other harmful substances. Stricter regulations are forcing shipyards to invest in advanced wastewater treatment systems to remove these pollutants before they are discharged into the environment. Additionally, shipyards are implementing measures to prevent spills and leaks, such as double-hulled ships and improved ballast water management systems. The use of more sustainable materials is also gaining traction. Shipbuilders are exploring the use of recycled steel, lightweight composites, and alternative fuels to reduce their reliance on virgin materials and minimize their carbon footprint. The goal is to create a circular economy for shipbuilding, where materials are reused and recycled whenever possible, reducing waste and minimizing the industry's impact on the planet. Section 4. When steel defies design engineering, challenges on a grand scale. Building colossal ships tests human ingenuity with engineering challenges. Steel's behavior is influenced by temperature and welding stresses. Ships must withstand waves, saltwater corrosion, and wind loads. Engineers use computer modeling to predict ship behavior in various sea conditions. Welding large steel sections can create residual stresses. Skilled welders use techniques and heat treatments to ensure weld integrity. Weight management affects ship stability, speed, and fuel efficiency. Integrating complex systems on ships is a daunting task. Engineers' ingenuity ensures ships navigate oceans safely and efficiently. As the sun sets on bustling shipyards, casting long shadows from towering cranes and half-built hulls, it's impossible not to feel awe at the scale and complexity. These ships are floating cities, vital links in global trade. Each ship carries the hopes of shipbuilders and crew, the merchants whose goods it will transport, and the consumers who benefit from its journey. These vessels are symbols of global interconnection, our fates intertwined by the flow of goods, ideas, and people. For all the technological advancements in shipbuilding, from computer-aided design to robotic welding, it's crucial to remember that at its heart, this industry is about people. Behind the impressive feats of engineering lies the dedication, skill, and commitment of countless individuals. The shipbuilder's craft demands physical strength, technical expertise, and artistic vision. From welders to electricians, pipe fitters to carpenters, every member of the shipyard team plays a vital role. These are not just jobs, they are callings passed down through generations. The next time you see a ship on the horizon, appreciate the unseen hands that guided its creation. As the shipbuilding industry looks to the future, it faces a dual challenge: to meet the ever-growing demand for maritime transportation while addressing the urgent need for environmental sustainability. The traditional image of shipbuilding is undergoing a profound transformation driven by stricter regulations and growing consumer awareness. The quest for greener ships is multifaceted, encompassing every aspect of a vessel's life cycle, from the materials used in its construction to the efficiency of its engines and the management of its waste streams. Shipyards are turning to lightweight, recyclable materials such as aluminum and composites to reduce weight and emissions. Advanced hull designs minimize drag and turbulence, allowing ships to glide through water with less effort. The engine room is also undergoing a green revolution with cleaner burning fuels and scrubbers. Battery-powered and hybrid propulsion systems offer zero-emission shipping for shorter routes. Sustainability in shipbuilding is not just an environmental imperative, it's a smart business strategy. Fuel-efficient ships are cheaper to operate, giving owners a competitive advantage. The story of shipbuilding is one of human ambition, ingenuity, and our fascination with the sea. From dugout canoes to colossal container ships, our desire to explore and connect has driven shipbuilding. As technology advances, the future of shipbuilding promises to be even more transformative. Autonomous ships guided by AI are becoming a reality. Advanced materials will lead to larger, more efficient and environmentally friendly vessels. New propulsion sources, from renewable energy to nuclear fusion, will push maritime boundaries. Yet, the human element remains at the heart of shipbuilding. Skilled hands, guided by passion and expertise, will continue to transform dreams into reality.